Okay, this is part 5 of lesson 5.4. This is our last video. We're just going to do one last problem, a story problem. It says Campbell Manufacturing produces circuit boards for televisions and for computer monitors on their production line. The production line can produce a combined total of up to 100 circuit boards per day. Each TV board uses 2 microchips and each monitor board uses one of the same type of microchip. Today, the factory has only 120 microchips on hand for production. Use X to represent the number of TV boards and Y to represent the number of monitor boards. Create 2 separate linear inequalities that represent 1. The total production capacity, or up to 100 circuit boards per day. 2. The total microchips that can be used in producing both types of boards, or factory has only 120 microchips on hand. So let's talk about what that looks like. So again, let's label our variables. X equals TV boards. Y equals monitors. Okay? And for the first one, we know based on the information that it's being given, the production line can produce a combined total of 100 circuit boards per day. Doesn't matter if it's a TV board or a monitor. So we know that X plus Y can be less than or equal to 100. Okay, that's as far as we can go. And so if we rearrange that, y is going to be less than or equal to negative x plus 100. We also know, based on the information that we're given, is that today the factory has only 120 microchips on hand for production, and it tells us that each TV board uses 2 microchips and each monitor board uses one of the same type. So if we're looking at that from the perspective of, the total microchips that can be used, the factory, if they only have 120 microchips, let's think about what we're talking about here. So monitor board uses 1 of the same type of microchip. TV board uses 2 of the same type of microchip. So if we want to set up an inequality that kind of shows this relationship, we know that we're going to need essentially double the amount of chips for TV boards than we do for monitors. However, the way this would look as an inequality is going to be x plus 2y is going to be less than or equal to 120. And the reason for this is we know we need double the amount. We need double the amount, but we can only make 100, and we only have 120 microchips on hand. So really it's, this one that limits us. So that's why we're going to put 2 on the y instead. And then we can rearrange this equation. 2y greater than or equal to negative x plus 120. Oops, sorry, 120. We're going to divide both sides by 2, so y is less than or equal to negative 1/2 x plus 60. Now, if we want to show this in graphical terms, pull this up so we can see here. We can go up by different values just to kind of simplify, since this one has a y-intercept of 100 and this has a y-intercept of 60. We're just going to pretend like we've started at some higher spot. We're going to say that this is 50, 60, 70, 80, 90, 100, 110, so on and so forth. So we know that the first one, y is less than or equal to, and then over here these are numbers of chips or boards, 1, 2, 3, 4, 5, 6, 7. So we can number those normally, so on and so forth. So we know that the first one starts at 100 and it has a slope of negative x. So that means every time we go over 1, we go down 1, which doesn't take us down too far. We'll put a point there, and we can see that we've got some sort of a line. Again, we know y is less than that, so it's got to be less than that quantity. And then for the other one, y is less than or equal to negative 1/2 x plus 60. Again, start at 60, and we know every time we go over 2, we're only going down 1. So it's a much more gradual decline. And we know that below these quantities, that's where this is going to end up showing us like what they can actually make in this factory in terms of microchips. All right.